Take down the next numerical. Design a suitable cooling tank with cooling tubes for a 500 kVA transformer with following data. The transformer dimensions are 100 cm in height, 96 cm length and 47 cm width. The total losses are 7 kilowatt. Allowable temperature rise 35 degrees Celsius. Full stop. Take clearance along height 40 cm, along length 14 cm, along width 30 cm. Determine number of cooling tubes and show the possible arrangement considering provision of tubes improvement in convection by 40%. Write on the given things. Height of transformer is 100 cm. Clearance along height 40 cm. Width of transformer 96 cm. Clearance along width 14 cm. Breadth of transformer, that is BTR, 47 cm, and clearance along breadth delta B 30 cm. If the values of delta H, delta W and delta B are not given, you know that you have to consider the default values. And allowable temperature rise is theta is equal to 35 degrees Celsius, and the total loss is 7 kilowatt, which is nothing but 7000 watts, and the rating of transformer is 500 kVA. As mentioned earlier, to solve this kind of numericals, you need to first find out tank dimension, and then next temperature rise, and then next surface area of tank, then area of one cooling tube, and then number of cooling tubes, and then the arrangement and schematic of cooling tubes. First, let us calculate the tank dimension. Ht is equal to Htr plus delta H. Substitute the values. Therefore, Ht is equal to 1.4 meter. Similarly, Wt, that is width of transformer tank, is 1.1 meter. Breadth of transformer tank Bt is equal to 0.77 meters. Next, we are supposed to calculate the temperature rise, that is theta R. So we know that total losses by plain tank without cooling tubes is given as W is equal to 12.5 St theta R. Here W is given, St we don't know, theta R we are supposed to calculate. So first let us calculate the surface area of tank, that is St. We know that St is equal to 2Ht into the bracket Wt plus Bt. Substitute the values, you will get the surface area of tank as 5.23 meter square. Therefore, using the equation W is equal to 12.5 St theta R, we can calculate theta R value by substituting the values. We are going to get theta R is equal to 107 degrees Celsius. It means that without using cooling tubes, the temperature attained by a transformer is 107 degrees Celsius. Now, as per the numerical, we have to restrict the temperature rise to 35 degrees Celsius. So, to bring down the temperature from 107 degrees to 35 degrees Celsius, we need to arrange some cooling facility. And here we are going to provide a cooling tubes. And by using cooling tubes, the convection will improve by certain percentage. According to this numerical, it is given that 40% will be improvement in convection. So let us continue. Therefore, the number of cooling tubes required to restrict temperature rise to 35 degrees Celsius, W is equal to 12.5 St theta plus 9.1 At theta. 9.1 because in numerical it is given 40% improvement. From the above equation, you can calculate At is equal to 14.79 meter square. Next, let us calculate area of one cooling tube, that is 81 is equal to pi dt Lt. Dt, if it is not given, by default you can take it as 5 centimeter, and Lt, if it is not given, you can take it as 90% of total height of transformer tank. So therefore I am writing it as 81 is equal to pi into 0.05, that is 5 centimeter in terms of meter, into 0.9 into the bracket 1.4. 1.4 is the height of transformer tank. Therefore area of one cooling tube is 0.198 meter square. So the number of cooling tubes can be calculated as n is equal to 80 by 81. Substitute the values, I'll get the total number of cooling tubes 75. Next, let us understand the scheme and arrangement of cooling tubes. The spacing between tubes is 7.5 centimeter by default. Therefore, the number of tubes arranged along the width can be calculated as the width of transformer tank divided by 7.5. So therefore the answer is 14.6. So after rounding it off to the nearest value, it is 15. Similarly, number of tubes along breadth is equal to the breadth of transformer divided by 7.5. It is 10.25 and the nearest value is 10. It means that along the length we are going to place 15 cooling tubes and along the breadth we are going to place 10 cooling tubes. To draw the schematic arrangement, first draw the plan of a transformer. Plan of a transformer means you have to draw the length and breadth. So as shown in figure, we have to draw like this and then next start arranging from the first cooling tube. So along the length we are going to place 15 cooling tubes. So that's why I'm writing it from 1 to 15. Then along the breadth I'm going to place 10 cooling tubes. So 16 to 25. Then along the length again 15. So therefore I'm writing it from 26 to 40. Then along the breadth again 10 cooling tubes, 41 to 50. We know that the total number of cooling tubes required are 75. But after using this arrangement, only 50 are arranged. So remaining are 25. So let us understand how to place these remaining 25 cooling tubes along the length and along the breadth. First divide 25 into equal part. So when you are dividing it equally, it will be 12.5, 12.5, which is not possible to place half of cooling tube. So let us write it as 12 and 13. Then next, again I am going to divide 12 into two parts and 13 also into two parts. So I'm going to divide 12 into two parts, that is 6 and 6. But we know that along the length we can place 15 cooling tubes. So half of the 15 is 7.5. So what I'm doing, along the length I'm taking 7 cooling tubes and along the breadth 5 cooling tubes. Similarly, this 13 I'm going to divide into 7 and 5. But we know that along the breadth we can place up to 10 cooling tubes. So I'm writing it as 7 and 6. It's not mandatory to write 7 and 6. You can write it as 8 and 5 also. No problem. Next, so in second arrangement, we know that along the breadth we are going to place, along the length we are going to place 7 cooling tubes, and along the breadth we are going to place 5 and 6. So let us do this one. So the last cooling tube placed along the breadth is number 50. So let us start with 51. And how many are going to place now? 7. So therefore 51 to 57 I am placing along the length. Then next number is 58. Along the breadth how many? 5. So 58, 59, 60, 61, 62. Next 63 to 69, totally 7. Then next along the breadth how many now? 6. That is 70, 71, 72, 73, 74, 75. So the total number of cooling tubes required are 75, and we have placed all the cooling tubes along the transformer tank. So this is how your schematic and arrangement of cooling tubes completes. Thank you.